Hello my friends, Uncle Misha is here, and today we are looking at another Dollarstore Miracle. This time, you probably recognize the most familiar brand, Tech One. And this time we have waterproof LED light, dynamic lighting for parties and home decor. Yeah, with remote control, multi-purpose use. Dollarama, Montreal, Quebec, Canada, made in China, of course. 13 static and 2 dynamic color settings, IP68 to light up vases, bowls on any water-filled containers. It's interesting. For up to 30 minutes. We have to check what is the power consumption of this little thing. Control color and brightness with included remote. 13 AAA batteries not included. Okay, well, we can certainly circumvent that. So let's just take a look. What do we have here? If it was our hard-earned, how much I paid for this shit? A few dollars, I'm pretty sure. Ta-da! Alrighty. So okay, let's remove this crap here. Let's hide this. Right out of the box we have this thingy and we have remote. Then plastic goes away. Remote is, I think it's like super generic remote. It's kind of funny that probably they did include CR2025, the battery for the remote, but they did not include the batteries for this thing. Is it magnetic? No, it's not. Curious, why do I need this? Oh, it's just for buoyancy. Like if this thing is supposed to be like in some sort of container, water container, it's supposed to be buoyant. Right, so right there, I thought this is the back side, but turned out to be this is the front side. Actually, those are 1, 2, 3, 4, 5, 6, 7, 8, 10 LEDs. 10 LEDs. Okay. Let's just disassemble. It's sort of kind of already super easy to disassemble here. Just this whatever it is. Is it like a motion sensor? Oh, it's for infrared receiver for this guy. Duh. Okay, that's good. Okay, so well, I mean, we're already here, so just open it up and see. We have 3 super flimsy how do you call them? Little tiny self-toppers, little super tiny, they're like 2mm ones. Ba-bam! Wow, okay, so here we are. That's what we have. Infrared receiver, some kind of microcontroller. Let me take a look what kind of microcontroller it is. Supposed to be microcontroller. I'm just curious, what kind of LED are those? Are those like our favorite? Oh my god, this looks super dusty here. What? Yikes. I'm curious, what the hell was it? Like it's like some kind of crud everywhere. Jesus. So we have battery compartment, receiver, which is supposed to be probably not crooked like this, supposed to be probably sitting right here flush with the PCB, because I mean technically you're not gonna receiving from the side, you're gonna receiving from the top, but who knows, maybe an angle it's gonna kind of go both ways, like to the side and from the top. Yeah, I don't know. Right, are those NeoPixels kind of style? Yeah, it's be nice to check. So let's just take a look something here. How do they connect it? Because if they are NeoPixels, they will be connected in series, because data pins are connected. They are essentially cascaded one after another. So if they are, this is actually pretty cool. We have 10 NeoPixels, well, Chinesium probably NeoPixels, for a few dollars here. Let me zoom in a little bit and we kind of can reverse engineer what we got here. So guys, let's quickly check what kind of setup and arrangement we have here. First of all, let's see how those LEDs are connected. So I am in diode mode over here, and let me poke around those LEDs and see
I'm wrong. And see where we are. Okay, so I hope you see that there is a red light going on here. So this is blue and this is green, and as you notice, all of them are lighting. So essentially, they all driven simultaneously. So the color change will be simultaneously, like color will be modified in same time. Also, we have 3 transistors right here, and transistors read, I think they read 3JY. As far as I know, 3JY is a NPN, regular NPN transistor. And essentially it's gonna have a collector. I think this is base and this is emitter. So these, if I remember it correctly, so this is gonna be connected to a microcontroller to be driven. So it's gonna turn on and off the transistor. Collector gonna be connected to the. Let me see how it's gonna be connected. Is it? Let me go in this mode. Just this and see if it's connected to this resistor. Yeah, okay, this resistor is only 2 ohms, so technically this resistor has to be connected to collector, and it has to be connected to LED. And let me see what color this, for example, particular transistor is responsible for. So this is green. Okay, so current is flowing through this resistor, and this is green, 2 ohms, a load resistor or a limiting resistor, I mean. So now we have to figure out how it's connected to our controller. Pretty much for other colors it's going to be repeated the same. So let me find collector for this guy, and you see this is blue, and this transistor is red. Red is really dim, and the blue is nice. Sorry, this is blue is nice and green is the best. Okay, so is this red? Red. For some reason this is 4.7 ohm resistor right here, so it's weird. Okay, so now we have also those resistors right here. They are, what do they say? Oh, so tiny. 10-2, so they are 10-2 or 21. It's really hard to say, actually. I think it says 10-2. So it's like 1 kilo ohm resistors. Yeah, I hope I'm not crazy. Yes. It's a 1 kilo ohm resistor. On these guys supposed to be connected, I think, my hypothesis here, that base of this connect to, let's say, one of these transistors. It's clearly not this one. Clearly is this one. So this base connected to this transistor. Okay, resistor, sorry, base of this transistor connected to this resistor, and this side supposed to be connected somewhere to the microcontroller. Let me probe it in such a way that I'm not gonna block the camera, so we just need to figure out where exactly it is connected. Oops. Okay, so it is connected to this pin. Well, I mean, so essentially I'm just keep probing it with in ohms mode to figure out where is the lowest resistance on what pin. Clearly not this one, clearly mega ohms, nothing, mega ohms, ohms. So this transistor driven by this 1 kilo, so it's a base resistor, and this base resistor is connected to this particular pin of the microcontroller, which is pin 1, 2, 3, 4, 5, 6. So correspondingly, let's assume that this resistor, 1 kilo ohm resistor, is connected to some of its neighbors, particularly to this one. So pin 5 is red, pin 6 is green, and I assume there is another resistor, unless I got sidetracked. Here's another resistor, and it's gonna be pin 7. All right, 5, 6, and 7 are corresponding to particular colors. So pins of microcontroller 5, 6, and 7 connected to 1 kilo ohm resistors, which driving bases of those Y3J transistor. How are they? What are they? J3Y transistors, and Bob's your uncle. And then we have also the 2 ohm current limiting resistors and emitter. Let's figure out where is emitter connected. So we have our base connected to microcontroller, collector connected to one of those LEDs, and emitter is supposed to be connected to. So I forgot if I don't remember if I mentioned. So there is a protection diode right here. So it goes here's our negative terminal. Is it negative? Yes, it is negative terminal. And here we have this protection. I think it's a protection diode, like I don't know what the other purpose of this diode right here, because it's in between a negative terminal of the battery and for example, this diode technically it looks like it protects the whole circuit from reverse polarity. That's the only explanation I would have. So our emitter is connected here. Yeah, so, and all emitters are connected to this, I assume, protection diode. Okay, and this protection diode goes to negative. It's a negative terminal. So here we are. This is what we have. So essentially, we have very simple schematic where there are 3 transistors driving a whole bunch of essentially 10 LEDs, and yeah, there is a little firmware is flashed here, and this little infrared device is connected to, what pin is this connected to? One of those 3, I guess. Mega ohms, whatever. Alright, so this pin is connected to this pin of the microcontroller. So realistically, or actually it is reading the information from the microcontroller, and 2 others, from the infrared sensor, and 2 others are, this clearly is positive here, and I assume this is gonna be power. Yeah, so essentially those 2 is powering this device, and this one is reading information, and it's connected to this pin of the micro. Right, so this actually gives us information on this device. I think I captured everything necessary, and it is, as you see, it is very, very simple. Technically, if you want to make it a little bit more complicated, or for example, a remote control, you can remove this guy and built in, if you have this tiny digistump microcontroller, for example, whack it somewhere on the side here, just replacing this microcontroller altogether. Or if you have some little teeny tiny Bluetooth control device, you can do that. Not sure if it's economically feasible, but clearly yes, you can do that. Okay, so let's try to actually power it on and measure different power consumption, like currents in different modes, like when all LEDs are lit and partially LEDs are lit in different level of brightness. So I'll try to use my power supply, current limiting power supply, 4.5 volt. I think that's gonna be working as a treat.
Okay, my friends, now we figure out how this thing works, so let's try to play with this remote and see how much this little guy consumes energy, because from what was actually written right there on the box, it's going to last only for quite short period of time. So I want to understand how much milliamps or amps, in matter of fact, this tiny, or this not too tiny, this LED consumes, or a whole thing. So first of all, let's take a look how much it consumes in kind of standby mode, and see how much it consumes while I put different brightness of the lights. So for that, we're gonna use my 10 mAh power supply. We set it to, okay, let me. So we set it to 4.5 volt and 500 milliamp as the current limiting. So I think that's probably a little bit too crazy, and but I think it's going to be good enough. So let's try to hook it up and try to observe polarity. It's negative. And negative goes, I think I can do something like that. Or maybe something like that. Alright, so positive, negative. Okay, it's not, is it holding? It's not cooperating. Just like this. Okay, so let's try to power it on. A little screwdriver. Oh, yeah, I forgot to pull this top. Ta-da! Okay, I think it's too bright, is it? Yeah, let me reduce. Okay, I think this is gonna be better, right? It's just like that. So it's a bit dark around, but I think this is gonna show those, I hope it's gonna show those red lights. Okay, something like, maybe something like that. Because on my screen right here, they do show as actually white. So that means they are pretty bright. So color may not be actually coming out properly, potentially. All right, yeah, so LEDs sometimes straight up, it's really hard to shoot. So this is right now consuming, as you see, 130 roughly milliamp. And let's shut it off because I kind of forget. Oh wow, it's consumes almost nothing. According to my 10 power supply in off mode, which is still probably in standby because it has to be reading this infrared sensor like constantly, or infrared transistor or diode, whatever it is. So let's power it on, and I'm not even sure what kind of brightness is this. Let's try to max it up with this. Okay, I'm not sure if it's maximum. No, it was probably maximum. So minimum brightness, as you see, is 12 milliamp. Let's do maximum. I'm holding. I'm not sure if I have to keep pressing it. The maximum brightness is 129, 130 milliamp. Only just our LEDs working. Let's do just green LEDs. Boom! We have 124 milliamp. And the lowest, oh, it's kind of annoying and have to poke, 12. Pretty much the same story. Yeah, when you press and hold, it does nothing. You have to poke, 125. Let's do blue. Blue is 124. So all three LEDs consumes essentially 130 or 125 milliamps, something in that range. So essentially, when I hit white, it's gonna pretty much half an amp. Or 400 sorry, what I'm talking about, it's gonna be almost 400 milliamp, close to. Okay, let's hit it. Boom, 354. I thought it's gonna be like 370 or something. So yeah, well, it's brightish actually, and it's not white. It's sort of off-white, more like cold. Actually, when you squint on it, you actually see each individual LED. Right now, I'm squinting, and probably because of the aperture of my eye is actually reduced, and brightness is reduced, I can see each individual color right here. So yeah, it's sort of like off-white, I would say. So what else? It has this reset button. See what's gonna do. Reset to default, and default is full 100% brightness red. So let's just shut it off. No, wrong. Let's just power it on. Do, let's say, green. Do off and do on. Okay, so it's by default starts from red. So it's not like it's remember your previous settings. It's relatively dumb. Okay, so let's check some other colors and what they have. So they have this orange. Wow, ish, orange-ish. Let's say this yellow. Well, yellow-ish. It's more like green. That's, yes. I'm not sure what the heck is that supposed to mean. Is it black? The cyan is actually looking nice. This blue is whatever. Purple is ish purplish. Brown or cherry, whatever. It's okay. And this one, purple, is okay. So, and white. It's probably the highest brightness. 350, 360 milliamps right here. You see that on the screen. So let's take a look what kind of animation this thing has. Let's do fade. Curious, I think it's gonna fade regardless what color you choose. It has this preset color pattern. It's just gonna go through it, I think. Let's do, let's say, green. Stop. How to stop it? Reset, I think. Let's do green and do fade. Yeah, I think it starts from the same pattern no matter what you choose. Okay. Yeah, it's relatively dumb in this regards. Do reset. Let's do jump. Okay, so it does pretty much the same, but without fading. It just keep cycling through like a set sequence of color, and the number of colors probably about 8. 1, 2, 3, 4, 5, 6, 7. Okay, one more time. 1, 2, 3, 4, 5, 6, 7. 7, not even 8. Right, that's pretty much it. So, can you do brightness during fade? Okay, when you hit brightness during the fade sequence, it stopped the sequence. Let's do fade jump again. Oh, but it remembers it. Let's do brightness. So essentially brightness, changes the brightness, pauses the sequence. It's very interesting. It's kind of funny that a fade and the brightness is not getting paused. So if you hit this, it's not gonna do anything. Like, yeah, interesting. Like it's hilarious how all this software, what kind of software solutions those guys choose who actually program this thing. Oh, I so wish to know what kind of microcontroller is this. Alright, so we figured out, so at 4.5 volts, this thing can consume minimum 12 milliamp, maximum 340 milliamps. So, unfortunately, there is no like a gradual preset of the brightness. For example, you cannot set 30, 40, 55, whatever percent. You have to really, go minimum, for example, minimum, like, right now it is 41, right? Go minimum, and then let's say do red minimum, 12, and then you like, oh, I want like 30%. 1, 2, 3, 30%. 4, 5, 6, 7, 8. No, 7. So 7 steps. 8 steps essentially. 1, 2, 3, 4, 5, 6, 7, 8. Yes. So this thing has 8 steps of brightness, and that's pretty much it. I don't know what else I can. And reset doesn't reset brightness, by the way. Oh, whatever. Let's shut it off. Let's turn it on. Wow, it remembers brightness. This is amazing. Okay, if it's gonna remember brightness when I should like do this. Curious if it has some kind of flash memory. Woo! No, it does not. It does not. So it doesn't have flash memory of any kind. It has probably a little bit of RAM. That's it. But when you do off and then on, yes, it does remember. So as long as you apply voltage, this thing gonna remember your some of your settings. Alrighty. Yeah. It's kind of useful, interesting toy. So there are a few things you can use it. For example, you can put it inside some of your fixtures, and you can make some basic illumination. You can put it in your vase with flowers or with like marbles and things like that to make and have some cool illuminations. But illumination pattern is going to be pretty basic unless you want to keep it at a certain color, and you have to keep it at low brightness. So for example, 12 milliamps, like I have it right now, as you see on the screen. And in this case, it's gonna last probably way longer than at 1, 2, 3, 4, 5, 6, 7, 8. And 130 milliamp, boom, 360 milliamp. In this case, it's gonna last like way less, many times less. Okay, so is it any useful? Yes, it is useful, especially if you would be able to remove this, connect, maybe remove this. So for example, you can replace this microcontroller with your something, let's say, as I mentioned before, some Bluetooth enabled development board or microcontroller, and you can have Bluetooth controlled RGB light. Well, it's still going to be limited because those are not NeoPixels. If those would be NeoPixels, that would be priceless. This thing would be priceless. You could do amazing things. But in this case, yeah, it's going to be just basic light, but it's still gonna work. And then obviously in this case you can limit the current to some meaningful level, because a 360 milliamp battery is not gonna last long. Even if you put some good lithium polymer battery, still not gonna last, because that's quite a bit of current. So for example, I have 750 milliamp hour battery. It's gonna last on the tops 2 hours. So yeah, it's gonna be pretty much useless. So you have to limit the current of those LEDs. That's gonna be it. I think this is sort of okay. Dollarstore Miracle verdict. Is it was $4? Probably not. Its price is $2. My price is $2. So tell me, what is your price? Are you okay to pay $4 for this, or this actually worth nothing to you? Okay, so, and guys, thank you for watching. See ya next time in another episode of Inside Out Electronic, where we take apart things. And ciao, stay safe.